So you're playing this hole in mini golf and you need to put the ball into the hole by ricocheting off of this wall. Both the ball and the hole are the same distance from the wall, so you can hit the ball at the midpoint of this wall and it will bounce into the hole by symmetry. Simple enough, right? Well, mini golf holes aren't usually as simple as one wall bounce. They might have multiple walls to bounce off of, advanced ricochets, curved walls, hills, rough patches, or pipes. How can you win on these more complicated holes? This video will only focus on ricochets on flat courses, so any other features like water or mounds won't be covered. So let's try to solve another hole with one flat wall bounce, but there won't be any convenient symmetry in this hole. When an object bounces off a surface like this, the angle of incidence, which is this angle, equals the angle of reflection, which is this angle. By the way, we're treating the hole and ball as points, each at their respective center. Since the angle bisector of the bounce point is perpendicular to the wall, these two angles are equal. Now if you reflect the path part after the bounce over the wall, you get that these two angles are the same, so this is a line. If this path goes through the hole, then the path's continuation without a wall passes straight through the wall's reflection. The point where the ball needs to hit the wall is the intersection of the wall and the line containing the ball and the hole's reflection over the wall. Look at this hole now. Where should you hit the ball to go directly into the hole? The thing about this hole is that if you try to bounce it off of the wall, it will hit this small end instead. What you need is to use this wall to get a better angle on the other wall, like this. Let's label the first and second bounce points A and B respectively. We don't know where A and B are, but B is defined based on A's position. If we manage to find where A is, we can locate B by finding the reflection from the hole over the B wall. Actually, no matter where A is, the other endpoint of the segment will always be the reflection of the hole over the B wall. Now that we know exactly where the ball should bounce after hitting A, we take the reflected hole as the new hole and find A as you would in a one-bounce course. Reflect the new hole over the A wall, then find the wall's intersection with the line from the ball to the new hole's reflection. To recap a two-bounce course, reflect the hole over the second wall, then reflect that point over the first wall. If you hit the ball directly at that point, it should intersect the wall at A, bounce to B, and reflect into the hole. Try to come up with a way to use this strategy to solve three-bounce courses. Think about how the reflections can simplify the courses to a lower bounce course. You may have come up with something like, reflect the hole over the third wall, then reflect that new point over the second wall, and reflect that new point over the first wall. If you aim at that point, then the ball will reflect into the hole 3 times. The first reflection turns the course into a 2-bounce course, which we know how to solve. By the same logic, we can solve 4-bounce courses by reflecting over the fourth wall to turn that into a 3-bounce course, which we again know how to solve. Generally, for any flat course that is only flat walls, reflect the hole over the walls in reverse order of ball collisions, then aim at this point. Because of all of the symmetries, the distance from the ball to this new point is the same as the length of the ball's path with all of the bounces. Think about this for a moment. All of these segments of the path can follow the same reflections as the hole did to build the segment from the ball to the new point. Note that you can't just use whatever orders of walls that you want. For example, this obviously doesn't allow you to go straight to the hole, since it'll get blocked off by this wall. But if you find a route that would make sense, then you can use the reflection strategy to find where to aim. But if you can't, then just take the L and use multiple strokes. Anyway, by this point, you've probably thought about how actual mini golf courses have curved walls in addition to the flat walls. Think for a moment about how a ball will bounce on a curved wall. After all, this video is for you to win mini golf. Or me, I guess. I don't really play mini golf that often. So a ball that hits a curved ball will bounce as if it hit a flat wall tangent to the curve at the point. Why is this? Since the ball itself is a point, everywhere on the curve other than where it collides has no impact on the ball's path. And if you zoom really far in on the curve, it approximately equals the tangent line. With the ball being an infinitely small point, zooming in does nothing to change its collision, so it'll just bounce off the tangent line here. And if you're faced with a circular obstacle, you can try to aim really well to ricochet into the hole, but you're probably going to miss because a slight change in angle will completely throw off the tangent line. Anyway, you may have learned from constructive chaos that ellipses have special mini-golf properties. If you don't know exactly what an ellipse is, I'll explain it in a moment, but a ball hit from one focus in any direction will always bounce directly to the other focus. No matter where you hit the ball, the tangent line at that point will always reflect the ball to the other focus. Okay, so an ellipse is the set of points defined by two key points, called foci, and a distance. We'll call it d. Take any point in the plane and find the sum of the distances to each of the foci. We'll call this the sum distance. If the sum distance is equal to d, then the point is part of the ellipse, and if you have every point in the plane satisfying this property, you get this ellipse. The overall form of an ellipse is this stretched oval shape. So that's an ellipse. But why does it have this universal bouncing property? To explain, I want to give you a little puzzle. You're given a line and 2 points in 2 dimensions. It's very important that both points are on the same side of the line. What point on this line has the least possible sum distance with these 2 points? I said that it was very important that both points were on the same side of the line. If they weren't, the puzzle would just be trivial. You can just draw the line between the 2 points, and wherever that intersects the line would be the optimal point. So look what happens if we reflect one of the points over the line. We get symmetry, and now these 2 lengths are equal. If we want the least sum, then we can just draw the line from one point to the other point's reflection over the line. Credit to Web Gokai for the puzzle, by the way. The reason I showed this puzzle to you is that the solution is the exact same as the solution to a one-bounce course. The point on the wall you should aim at happens to be the same point which minimizes the sum distance of the points, and vice versa. Back in an ellipse, any point inside of the ellipse has a lesser sum distance than the ellipse itself. Likewise, any point outside of the ellipse has a greater sum distance than the ellipse itself. Now, if you hit the ball at any point on the ellipse, it will bounce off of the tangent line. Every point on the tangent line is outside of the ellipse except for the point of tangency. Thus, every point other than the point of tangency on the tangent line has a greater sum distance than the point of tangency. And this is the same as saying that the point where the ball hits the ellipse has the least sum distance of any point on the tangent. And remember the puzzle? The point with the least sum distance will bounce from one point to the other point. And that's the reason that the ellipse works. Of course, I doubt you'll actually find an elliptical hole on a mini golf course, but it's still a fun concept to play around with. So yeah, you can use these tricks in mini golf, or billiards, or paintball maybe. I haven't played paintball, but I would imagine that paintballs bounce off of surfaces sometimes. Anyway, thanks for watching, and take care.